Back in 2015, we examined LED bulbs putting out as much light as 60-watt incandescent bulbs. We recently obtained several new LED bulbs to see how things have changed. The results are interesting. In general, the new bulbs we tore down have a much simpler mechanical construction and simpler electronics than those of 4 years ago. And the bulbs we dissected have much less in the way of heat sinking or EMI shielding than their older counterparts. As in 2015, we examined the top-rated bulbs from Consumer Reports. Fortunately, one of the bulbs we looked at made the list both in 2015 and today, so we could make an apples-to-apples comparison. That is the SlimStyle A19 soft white dimmable bulb from Philips Lighting. This bulb is unlike most others in that its LED plates shine light out to the side rather than up. This gives it a thin profile. It's more like a disc than a bulb. The packaging for this bulb claims the bulb distributes light over 360 degrees, but we still think it probably works best in a lamp with a shade that helps disperse light evenly.
The only component on the Philips bulb that spreads heat is a 2.5-inch diameter metal disc onto which the 26 LEDs mount, 13 to a side. And this disc doesn't seem to have changed much since 2015. You might expect to see LEDs staggered on the disc such that they wouldn't mount directly opposite each other in a mounting arrangement that would also help spread heat. But the LEDs on either side of the disc sit directly opposite each other. And both vintages of the Philips bulb carry a temperature-sensitive resistor on the LED plate, which probably helps manage LED heat. The circuitry found on the old and new bulbs is also quite similar, with the exception of an IC that the old version carried. That chip carried no identifiable markings, and we theorized it was involved in dimming and driving a single power FET on the board. The new version does away with that chip. In its place on the PCB are two small discrete transistors. The two transistors are consistent with a circuit that can generate a square wave drive signal that you might use as the basis of a pulse width modulation signal. Also on the board is a sizable transformer, as might be used for a forward converter topology. We think a forward converter topology is a good candidate for what we found here because it can provide galvanic isolation for the load and can reduce the voltage sent to the LEDs. So that would be our best guess for the type of supply feeding power to the LEDs. One final observation about the SlimStyle bulbs is that neither the old one nor the new one incorporates any kind of metal shielding, as you might add to prevent EMI. That would seem to indicate that the pulse width modulation frequencies involved must be pretty low.
We examined a second Philips LED bulb that got high ratings from Consumer Reports. This one is also dimmable, and it is simply called a soft white light bulb with a warm glow effect. But the electronics differs dramatically from the SlimStyle. We found 12 regular-sized LEDs and 3 smaller LEDs, roughly half the size of the others, all mounted on the metal LED plate. Also on this plate was an 8-pin IC carrying markings we couldn't identify, along with 14 resistors and 1 capacitor.
It's unusual to see an LED bulb use LEDs of 2 different sizes. It's also unusual to see this many resistors on a switching power supply circuit, particularly in the portion that seems to be in the LED output. The IC sitting on the LED plate is also a bit of a mystery. The power FET that actually drives the LEDs sits on the PCB, so it's unlikely the IC on the LED plate has anything to do with pulse width modulating the FET, a typical rule for ICs found in LED bulbs. There's also just 2 wires coming into the LED plate, so whatever the IC does has to take place using only these 2 lines. So it seems to us the little IC might have some kind of role in synthesizing a current source for driving the LEDs. You typically drive LEDs with a current source rather than a voltage source because their light output is sensitive to the amount of current they carry. Like the power supply in the SlimStyle bulb, this one also contains a transformer, which tends to indicate the use of some sort of forward converter topology. We also found a couple of small transistors on the PCB, as might be the basis for a PWM drive. Finally, it's interesting to note that this bulb uses a mechanical connector for electrical connections between the LED plate and the PCB, which is a step up. Bulbs back in 2015 typically just used soldered wires for these connections. And this Philips bulb includes metallization on the inside of the plastic shell holding the PCB. One might speculate the PWM frequency might be such that Philips figured it needed metallization as a shield for EMI emissions.
We'll end this session with a look at the dimmable Sylvania 72637 12-watt A19 Ultra LED light bulb. We dubbed this one the hand grenade because of its shape. It carries 6 LED plates, one on the top and the other 5 arranged around a big cast metal structure with a separate translucent cover for each LED plate. Each LED plate holds 6 LEDs. Discrete wires connect the LED plates together and form the connections to the bulb's PCB. This bulb first became available in 2014, which makes it one of the first relatively affordable LED bulbs to hit the market. The fact that it still occupies a spot in the Consumer Reports' top LED bulb list is probably a testament to its quality. Still, the construction practices it employs highlight the changes in the LED bulb design over the years. For example, you won't find modern bulbs employing big cast metal structures, and modern bulbs are more likely to use connectors for hooking the LED plate to the PCB.
The electronics on the Sylvania bulb were also what you might call previous generation. There's one 10-pin IC on the circuit board with unidentifiable markings, but which most likely implements a PWM drive for the 2 power FETs we found. There are also 2 small discrete transistors on the PCB, but they don't seem to be good candidates for generating the required PWM pulse train. The presence of a transformer also indicates that a forward converter is a likely topology. Another point to note is the presence of 2 beefy, though different, inductors. We're guessing the first inductor may play a role in power factor correction, judging by its board position. The second is almost certainly part of the converter circuit, but it's not clear why designers decided they needed 2 FETs to power 36 LEDs. Still, this is a previous generation design. They did things differently back in 2014.
Which also explains why it's unlikely you'll see any modern LED bulbs that look like hand grenades. With that, we'll fade into black on our LED analysis. For more teardown videos, go to eeworldonline.com.